When we differentiate this with respect to x, we get this is a constant times y. When I differentiate this with respect to x, I get in your mind, you can replace y by 15 and just differentiate.
Which is x.
But if I differentiate x, don't I get 1 times the constant? So if y is 15, when I differentiate this, do I get x or do I get 15?
15.
Yes. So that's it. This is 0. And yes, when I differentiate this, I get positive 11. Perfect. Now we differentiate. Say it again.
I have a question.
Sure, yes.
I thought when you were differentiating for x, you weren't allowed to have the other variable in the answer, or am I?
You are allowed to have a variable. But when you differentiate with respect to x, everything else is a constant. I cannot differentiate with respect to x and y at the same time. If I differentiate with respect to x, everything else is a constant. It has to be treated as a constant. If I differentiate with respect to y, everything else has to be treated as a constant, even if it doesn't look like it. Good. So now we differentiate this with respect to x. What do we get? Say it again.
2.
That's it. Very good. Now we go back and we differentiate with respect to y. Perfect. We can also jump here. This is already differentiated with respect to x. Now let's differentiate it with respect to y. What do we get when we differentiate this with respect to y?
Is it 1?
Exactly 1. Good. Now we go back and we differentiate the original function with respect to y.
Is it x plus 6y?
X plus 6y. This doesn't have y in it. This does have y in it. So when I differentiate y, I get 1 and the constant stays. When I differentiate with respect to y, I get 6x. And there is no y, meaning this is a constant. When I differentiate it with respect to y, is 0. Perfect. Now I can differentiate this with respect to x, because I have already differentiated with respect to y, and now the next step is to differentiate with respect to x. What do I get? And it has to be the same thing.
One.
That's it. Good. So now we already have differentiated with respect to y, and we need to differentiate the second time, second partial derivative of the function with respect to y.
6.
That's it. Just 6. This doesn't have y in it, so it's a constant at this point. When I differentiate, the constant is 0. This has y in it. When I differentiate with respect to y, I get 6. Very good. Any questions? Okay, so we have a function. This is the function. We differentiated. We found all derivatives. And now this is the first step. So this is the function. Step number 2, all derivatives. And in step number 3, what did I do here? This is my page 4 and page 5. Okay, here's our next step. In step number 3, we will determine or we'll set a system, fx equals 0 and fy equals 0. I'll explain in a minute what I'm doing. First step, we have the function. Step 2, we determine all 6 derivatives. In step 3, we create a system of 2 equations. I go back. Where is fx? Okay, fx is 2x plus y plus 11 equals 0. I go back and look at fy. Fy is x plus 6y equals 0. This is very similar to finding critical numbers. After we found the derivative, if you remember, we said the derivative equal to 0 or undefined. But in this case, we create a system of 2 equations in 2 variables, fx equals 0 and fy equals 0. Here I have the system. I have to, in step 3, I have to solve this system. Here's how I do it. I rearrange the first equation as 2x plus y equals negative 11. And I solve the second equation for x, and I get negative 6y. I will use substitution. Replace x by negative 6y in the first equation. 2 times negative 6y is negative 12y, plus y equals negative 11. After I substitute the x by negative 6y. Negative 6y times 2 is negative 12y. Then I copied y, equals symbol, and negative 11. So I have negative 11y equals negative 11, which makes y equal 1. If y equals 1, I have to go back and determine x. If y equals 1, how much is x? If y equals 1, how much is x?
Should be negative 6.
Negative. Very good. So we found the point negative 6 comma 1. In step number 4, the question is negative 6, 1 a max, a min, or nothing? Is negative 6, 1? Because we didn't have this with a function of one variable. We only got a critical number. This is a critical point. So we found a critical point. Is this critical point a max, min, or nothing? We have to conduct something called a d-test. A d-test. The d-test is the following. Is a number. We have to calculate this number. How do I calculate this number? fxx evaluated at negative 6, 1 times fyy evaluated at negative 6, comma 1 minus fxy evaluated at negative 6, comma 1 and squared. This will give us a number. So back to the functions and derivatives. fxx, I should be plugging in fxx. I should be plugging negative 6 for x and 1 for y. But it's already a constant. There is nothing I can do. So fxx is 2 times fyy. But fyy is 6. Otherwise, I would have had to replace x by negative 6 and y by 1, but there is nothing. Times 6 minus fxy. Nothing again. Very simple situation because it's 1. Good. So, again, here in fxx, I was supposed to replace, but I don't have anything to replace. It's just 2. It doesn't have x and y to replace anything. Same thing with fyy, same thing with fxy. So this number happens to be 12 minus 1, which is 11. Okay, now this is our conclusion. Okay, in number 5. If D is positive, then I have to look at two different things. And D is positive in this case because it's 11. Then I have to look at two things. If fxx at negative 6, 1 is less than 0, which is not in this case, negative 6 comma 1 will be a max, but it's not in this case. If fxx at negative 6 comma 1 is positive, then negative 6 comma 1 is a relative of course, is a relative minimum. And this is our case. So again, when the d-test gives us a positive number, then I have to look at fxx, only fxx. If it's negative, but in this case it's 2. If it's negative, then this point is a relative max. If it's positive, which is our case, it is positive, then negative 6 comma 1 gives a relative minimum. Now, if d is less than 0, nothing. Negative 6 comma 1 is nothing. If d equals 0, test is not applicable. So the d-test has three options. If d is positive, then the critical point we have is either relative max or relative min. If d is a negative number, because d can be any real number. If it's positive, then I look at fxx, and then I know. If it's negative, this point is neither a max nor a min. If d is 0, the test is not applicable. In the final step, now I know that negative 6 comma 1 gives a relative minimum. I find the relative minimum. I have to go back to the original function and find the relative minimum. So where's the original function? Here it is. X squared plus xy plus 3y squared minus plus 11x. I calculate by replacing x by negative 6. So 36. And then negative 6 times 1 is negative 6. And plus 3. And then minus 66. This is the actual value, actual minimum value. So what do we have? Negative 66 plus 36 is negative 30. And this is negative 3, so negative 33. So this is the relative minimum. The critical point is negative 6 comma 1. Where does the relative minimum occur? It occurs at negative 6 comma 1. How much is it actually? What is that minimum? Negative 33. Now I want to show you here on page 570. I like those graphs very much. They're doing a very good job with the graphs. We are talking about three-dimensional graphs. As you see, x and y are the independent variables, and f, the function f, is the dependent variable. This is the way a relative maximum looks like. This is the way a relative minimum looks like. Because this is a surface. We are talking about three-dimensional space. Okay? It is possible for a surface to have more than one max, more than one relative max. This is what happens when there is a so-called saddle point. That's the so-called saddle point, which is neither a max nor a min for the function. Because as you see, you can say, but there is a minimum here. Yeah, but it's a maximum this way. Okay. Good. Let's work on another problem and determine max min. And let's choose anything you want. Where is it? What page is it? 576. Okay. Here it is. Let's choose. I chose this function. I chose function 2. Let's choose any function you want. And try to find its max min.
Can we do 13 or 14?
Yes, of course. Okay, so we have in 13 we have f of x comma y equals e to x squared minus 2x plus y squared minus 4y and plus 2. So let me make sure I copied it correctly. X squared minus 2x, correct. Y squared minus 4y plus 2. Very good. So we're asked to, yes?
That's all the exponent, right?
Yes. Everything is the exponent, yep. That's okay. That's quite all right. Good. So our first step is the function. Step number 2, all derivatives. So we have to find fx. Remember the rule. E to a function prime is e to that function times the function prime. We are differentiating only with respect to x. So in parentheses, all this function has to be differentiated with respect to x only. So what do we have?
Would it be 2x minus 2?
Very good. This is it, 2x minus 2. This doesn't have x, this doesn't have x, this doesn't have x. Good. Let's determine fy. Same thing, e to the function, I have to copy it, times the inner function prime. But now we differentiate with respect to y only.
Two y minus 4.
So it is 2y minus 4 indeed. Perfect. Excellent. Good. Now we have to find fxx, which is a little bit more difficult because now we have a product to worry about. Careful now. So now we have this times this. So when we find fxx, we have to use the product rule. This function prime times this plus this times this function prime. And the same thing for fy. Good. So fxx, the product rule. The first function prime is e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime with respect to x, which is the same thing. So then I have 2x minus 2 squared plus the first function times the second function prime. But the second function prime is only 2. Leave it alone because we only need to evaluate it. We're not going to do anything with fxx. Good. So now let's determine fyy. Same rule. First function prime, e to x squared minus 2x plus y squared minus 4y plus 2 times the inner function prime, which is the same. So then we have times 2y minus 4 squared plus the first function times the second one prime, which is just 2 e to x squared minus 2x plus y squared minus 4y and plus 10. And we have two more.